Now let's take a look at the fourth property. The fourth property says this: if you want to sum from m to n, then this is the same as saying you sum from 1 to n minus you sum from 1 to m minus 1. Now, how do you get this? Now look at the proof. Now the left hand side is actually summing from m to n. So the first term is um plus 1, plus 2, all the way until the last term un. Alright? Now this is the same as actually adding u1 plus u2 plus u3 until um minus 1 and subtracting the same thing here. Now the reason why I want to do this is because the very first term in bracket here is actually summation r from 1 to n of ur. Now the second bracketed terms is actually summation r equals to 1 to m minus 1 ur, and hence you have the right hand side. Now how do we make use of this? Now look at this example. Now you have 4 summation r from 3 to 50, and then I can always write this as 4, and if I want the lower limit to be 1, then it's just r from 1 to 50 minus from 1 to 2, and then I can separate them out as a sum of 2 different series. Now let's take a look at the last property. Now this last property is probably the most difficult to understand. Let's take a look at 5a and b separately. Now look at 5a. Now 5a says this. 5a says you want to sum fr, okay, from r equals to m to n. And then this is the same as sum fr minus k, where k is a constant, from the lower limit of m plus k to the upper limit of n plus k. Now, it's easier to look at this if it's a sum example rather than to look at all this. So that's why let's take a look at this example. Now I want to sum r squared from 25 to 51. Now sometimes, right, for questions, we may want to play around with the number here. Okay, we want to change this r to something else. Or sometimes we want to play around with the index here. We want to change 25 to something else, or 51 to something else. So what we can do is this. Now the sum is actually 25 squared plus 26 squared and so on. Alright, so take note of this. Now if let's say I want to change the r to r minus 1, then always remember this. The lower limit and upper limit must also change. If you minus a 1 to the r, then you must increase a 1 to the lower and upper limit. If you add some number to r, for example, you add a 1 to r, then the lower limit and the upper limit must also change. If you increase, you must decrease here. If you decrease, you must increase here. Okay? Now let's take a look at another example. If let's say I want to sum r squared from r is 3 to 10. And let's say I want to change this. I want to change this for some reason. I want to change this to r plus 3 squared. So the r has changed from r plus 0 to r plus 3. So the number in the function has increased by 3. So that means the number that I have here, I have to reduce by 3. So I will start from 0 to 7. Now likewise, if for some reason I want to change the r squared to r minus 1 or minus 4, for example, then what will happen now is I take away 4 here, means I must increase the lower limit by 4 and the upper limit by 4. Can you see this? It will be clearer when we look at some examples with this change of upper and lower landing.